Our client, Hungary Hydro Plus Limited, has been specializing in the sale of wastewater and drinking water circulation pumps, as well as the installation of complex water pumping systems for over 15 years. The company has extensive experience in water treatment and utility infrastructure and actively participates in various technical developments, particularly in the field of wastewater lift stations and wastewater control systems. WM Systems has been working in close cooperation with his partner in the utility services sector for many years, where our industrial routers have been reliably used to enable communication between PLCs. The challenge. Hungary Hydro Plus approached WM Systems with the task of modernizing an outdated process control system that spanned multiple locations and had to meet clearly defined technical specifications. The existing system included several legacy PLCs that were not capable of communicating with each other, making replacement unavoidable. The modernization required the deployment of new interoperable control units and the implementation of a state-of-the-art mobile communication infrastructure. The solution. Our partner selected WM Systems because we were able to deliver an industrial communication solution that ensured both reliable data transmission and seamless installation in space-constrained environments. The selected PLC-compatible router features low power consumption, mobile internet capability, and a design specifically tailored to industrial environments with limited installation space. One key challenge was the system's reliance on solar power, meaning that both the communication devices and water regulation components were powered solely by PV systems. Under these conditions, ensuring the router's stable operation with minimal power draw was critical. The selection process. Following on-site assessments and technical consultations, we recommended the DIN-Rail LTE router from our product portfolio. This device offered several advantages: a favorable price-to-performance ratio, rugged industrial design, compact 1U DIN housing, similar to a miniature circuit breaker, easy wiring, and reliable LTE connectivity. The router's form factor enabled smooth integration with existing field devices while also supporting the technical execution of the complex system architecture. WM Systems' technical team was actively involved in both system design and implementation. Implemented functions. The system was deployed across multiple locations with varying functional requirements. One of the core components was the installation of the DIN-Rail LTE router, which provided a private APN-based mobile communication network. It was supported by an IORS 485 data concentrator, responsible for collecting signals from digital inputs and relay outputs. Measuring the pressure. A primary objective was to measure pressure loss in real time following the booster pump stations. In a closed system, pressure levels should remain constant. Therefore, any drop in pressure could indicate water loss or equipment malfunction. The system was designed to instantly detect these anomalies and report them to the central monitoring center. The pressure measurement setup consisted of an Advantech 4 to 20 mA transmitter connected via Ethernet to the router, while the IORS 485 concentrator handled fault signal collection. Data communication was performed via Modbus TCP protocol, with transmission to the central monitoring system over the LTE network. The system was capable of issuing alerts, for example, in the event of a power fault, as for depleted PV battery, or critically low pressure, enabling timely intervention by operators. Example use case. In the event of a power failure, such as a discharged PV solar battery or critically low pressure readings, the system automatically sends an alert to the central control unit. Flow redirection system. The project also included the implementation of a solution that allows the water supply to be automatically switched between two separate water supply circuits using 5 valves. This function proved essential during service disruptions or planned maintenance. Control was handled by a Schneider M200 PLC, which responded automatically to commands issued from the utility provider's SCADA system. The PLC changed the water flow direction and input source as needed, while communication was again supported by the DIN-Rail LTE router. The DIN-Rail LTE router provided the communication backbone for the PLC network across all installations. Results. With the deployment of the modern LTE routers and upgraded control system, a stable, fast, and future-proof infrastructure was established. Operational reliability in water service increased significantly. failure rates dropped, service interruptions were minimized, and automation levels improved. The investment delivered a rapid return thanks to reduced maintenance costs and fewer operational errors. In summary, during the 2 phases of the implementation, which included the construction and installation of transition lines, a solar-powered pressure measurement station, manholes, and transfer points, all functional automation requirements were successfully fulfilled using just 29 DIN-Rail LTE routers deployed across the entire project. Conclusion. The cooperation between Hungary Hydro Limited and WM Systems is a benchmark example of process control modernization and the application of smart water technologies in the public utility sector. The infrastructure developed in this project also provides a strong foundation for future extensions, such as integration of additional sensors, for example, temperature, current consumption, ventilation, enhanced cybersecurity through the use of secure router models, adoption of MQTT or HTTPS-based data transmission, integration with cloud-based SCADA systems. WM Systems devices already support all of these features. If this case study sparked your interest, don't hesitate to get in touch with us.